The United States Department of the Treasury is concerned about the rising price of copper used to mint pennies. They propose to eliminate the penny and change the value of the nickel to 6 cents, naming this new coin the pickle. So, penny, nickel, pickle. Anyway, under this proposal, the new coins minted would be 6 cents, 10 cents, and 25 cents. And the question is, what would be the largest monetary value that could not be made using combinations of any whole number of these three coins? Alright, so we have coins now. This looks like a nickel, but it's now a pickle, and it's worth 6 cents. Okay? And then the dime is still worth 10 cents, and the quarter is still worth 25 cents. And, alright, so obviously, we can't make 1 cent. We can't make 2 cents, 3 cents, 4 cents, 5 cents out of these coins. Okay? And we could go through the list of, go through every number and then try to figure out what the greatest value that cannot be made is. But, so that's one way to do it. But I want to do it a little different way. I actually want to look at the units digits of the combinations of these coins. Alright, so we can take any number of nickels. So we could have no nickels. We can have 1 nickel, which would be 6 cents. We could have 2 nickels, which would be 12 cents. 3 nickels would be 18 cents. 4 nickels, 24 cents. 5 nickels, there's 30 cents. 6 nickels, 36. And if you look at the units digits here, just the units digits cycle 0, 6, 2, 8, 4, 0, 6, 2, 8, 4. If you kept going, it would just repeat that pattern over and over again, 0, 6, 2, 8, 4. Okay? And, it makes sense because a nickel is an even number, or the 6 cents is an even number, so you can only get even numbers with something that's worth an even number. If you add even numbers and even numbers, you can only get even numbers. Okay? So, and if we were to use this 10-cent coin, the dime, again, you're only going to get even numbers. Okay? Because it's not going to change the units digit of any of these numbers. So let's take a look at what happens when we add 25 cents. And that's the only way that we're going to get any odd numbers, is to add an odd number. So since 25 is odd, if we add 25 cents to these numbers, 25 cents to these numbers, what do we get? We get 25, 31, and here we have 37. If we add 25 to 18, we get 43. We get 49. We get, let's see, if we add 25 to 30, we get 55 cents, and so on. And you can see again, okay, here we get only odd numbers because we're adding an even and an odd, and we're going to get an odd number. But here we get the 1, the 3, the 5, 7, and the 9. You see that? So I can actually break it off here. And you can see that the combination of 6 cents and 25 cents, we can now, using some number of nickels and 1 quarter, we can get anything ending in a 0, ending in a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9. Okay? So if we just look at the units digits, we can figure out what's the biggest denomination, the biggest value we can make. So let's just go through, ending in 0. So actually, let me write that out. If we're ending in, okay, I'll make a little table here, I think. So ending in 0, then the first value we can make is 10 cents because we have the dime, right? And we can make anything ending in the 0. We can make 10 cents, 20 cents, 30 cents, 40 cents. Anything ending in 0 works. Okay, even 0 cents. We just don't have any. It's really not a value, but we don't have any coins with 0 cents. So we can create really anything ending in a 0. Okay, Ending in a 1. What's the biggest one we can make? Or the first one. The first one that we can make ending in a 1 is this 31 cents. Okay? And in order to make that, we got to combine a nickel, or a pickle and a quarter. Okay? And we get 31 cents. So the first one that we can make is 31 cents. Okay? Which means that, let me make another column in this table. We can't make what? We can't make 21, we can't make 11, we can't make 1. Okay? So we can't make any of these numbers ending in 1. But the first one we can make is 31 cents. Let's look at 2. The first one we can make is 12 cents, right? So we can make 12 cents, but we can't make 2 cents. Okay? Makes sense. Ending in a 3. Alright, the first one that we can make is 43 cents, looks like. So 43 cents we can make with a quarter and 3 pickles. Okay? So we can't make 33, 23, we can't make 13, and we can't make 3. Okay? So these are the ones we can't make. Let's look at the values ending in 4. Alright, 24 cents is the first one we can make. We make that with all pickles. Make 4 pickles make 24 cents. So that means that we can't make 14 cents and we can't make 4 cents. Alright, let's look at the 5s. 25 cents. Well, we have 25 cents. We can make 25 cents, but we can't make 15 cents and we can't make 5 cents with the coins. Ending in 6. Alright, looks like the first one that we can make ending in 6 is 6 cents, right? Because it's just 1 pickle, so 6 cents, so we can make anything really ending in 6. Alright, ending in 7. Well, looks like our first one is 37, so we can make 37 cents, but we can't make 27, we can't make 17, and we can't make 7. Alright, 8. Alright, the first one we can make ending in an 8 is 18. Alright, so 18 cents we can make, but we can't make 8 cents. Alright. And then 9, that'll be our last one because that's our last unit digit. And the first one that we can make ending in a 9 is 49 cents. So we can make 49 cents by taking 4 pickles and a quarter. Okay, 4 times 6 plus 25 gives us the 49 cents. But we can't make 39, we can't make 29, we can't make 19, and we can't make 9. Alright, so now we can see all the numbers that we can't make. So I was just looking at the units digit, looking at all the evens and odds, so there's only 10 cases. And so now let's look at the numbers we can't make and figure out what the biggest number that we can't make is. And if you look through here, obviously 39 is the biggest one we can't make. So the answer to this problem is 39 cents. That would be the largest monetary value that we can't make using combinations of these coins. Alright. So this is actually called, this problem is kind of a classic problem. Sometimes it's called the coin problem, or the Frobenius coin problem. This number here is actually called a Frobenius. See if I spelled that right. Frobenius number. I think it's just EN. Oops. Alright, Frobenius number. Okay. And there's another classic problem called the Chicken McNugget problem. It's another Frobenius number problem where Chicken McNuggets are only sold in certain size packages. So it's like 6, 9, and 20, and what's the biggest number of chicken nuggets that you can't get, using those quantities that they sell the chicken McNuggets in. Okay, so if you want to look at more of these types of problems, they're kind of interesting. Um, you can look up the coin problem or the Frobenius number or chicken McNugget problem. And but basically, whenever you have a set of numbers where there's no common factors, okay, so you can see here, there's common factors between the 10 and 25. Obviously, there's a common factor of 5, and then there's a common factor of 2 between the 3 and the 10, or the sorry, the 6 and the 10. But between the three of these numbers, there's no common factors. So the greatest common factor of 6, 10, and 25 is 1, right? So there's basically no common factors other than 1, okay? And when you have that situation, then you will get a biggest number. You will get a Frobenius number, a biggest number that you can't make with these values by adding these values, okay? And that kind of makes sense, because if I had 5 cents, 10 cents, and 25 cents, then I could only make multiples of 5. I couldn't make anything other than multiples of 5. So everything would end in a 0 and or a 5, right? So whenever you have numbers where the common factor, where there's no common factor, or the greatest common factor is 1, then you'll get a Frobenius number. So you can look at more of those types of problems. I wanted to have you think about one more thing. What if we wanted $1? Okay, we want $1.01. Okay, and we're going to assume there's still bills we're only dealing with the coins here, and there's still bills being produced. So that hasn't stopped. But the thing is, we could actually make $1 with these coins, 6, 10, and 25. We just can't make it we can't use a dollar bill. What would we have to do to make $1? We would need, okay, it's got to end in a 1, so we need a 6 cents and we need a 25 cent to get it to end in a 1, which gives us 31 cents. So we need 70 more cents. So we could make that, we could either have 7 dimes, or we could have 2 quarters, and 2 dimes. And then we can get $1, right? So, and okay, so what if you owed me 1 penny? If you owed me 1 penny, what could we do? Let's assume I have some money. Well, what you could do is give me $1, and then I give you $1 back, and then essentially you gave me a penny. So I don't know. Some of these problems are kind of interesting to think about. But so anyway, I've gone beyond what I intended to show you. But hope you enjoyed that problem.